Okay, so in this video, we're going to continue going over the fall semester final exam review, and I'm going to be doing questions 21 through 35. So this first question says, what are the horizontal and vertical asymptotes of the function? And so what we're going to do first is we're going to factor that numerator and denominator. So we're going to, if I can get my pen to work, we're going to find the factors of both the numerator and the denominator. So our factors of our numerator, x and x. What are the factors of 1 that add up to be 2? So that's plus 1 and plus 1. And then what are the factors of negative 4 that add up to be 3? That would be x plus 4 and x minus 1. So notice that nothing cancels out here, okay? So there's no repeated factor in the numerator and the denominator. So this is then f of x equals what we have. Okay, so we're going to find the vertical asymptote first. So to do that, we're going to set the factors of the denominator equal to 0. So that's going to be x plus 4 equals 0 and x minus 1 equals 0. So this is going to be x equals negative 4. Be great if I could write today, guys. And then x is equal to 1, because remember, I was going to do the opposite operation to move things. Then it also asks us about the horizontal asymptote. So when I do the horizontal asymptote, I recall that I'm going to take the leading coefficients right here, okay? So that means I'm going to do x squared over x squared, and that's really equal to 1 over 1, and that's going to be 1, which equals y. Remember, this is a horizontal line, so that's a y is equal to, whereas a vertical line is x is equal to. So the next one says, Kim simplified a rational expression and found an equivalent expression to be 6x plus 18 over x minus 3x plus 6. So, so what we want to do here is go ahead and see if any of these equal the one that's there. So this cancels out. So this would be 6 times x plus 3 over x minus 3. Well, obviously that's not it because the x plus 6 canceled out, so that's not it. The next one, we're going to get a common denominator, so I'm going to go ahead and multiply the numerator by the other denominator, so that's going to be x plus 6, so I can get a common denominator. And this one by x minus 3 over x minus 3. Remember, again, I'm trying to get a common denominator. So now I have a common denominator, so that's going to give me 4x plus 24 plus 2, or 2x minus 6 all over our x plus 6 and x minus 3. Okay. So 4x plus 2x is, this would simplify to be 6x. Then we are going to combine our other like terms, our constants. So 24 minus 6 is actually plus 18, and that is over our x plus 6, x minus 3. Okay, so that is the same as what we had up here. So let me go ahead and erase this because I'm thinking B is our answer. We're going to double check and make sure it is. But I think B is our answer. Actually, I know B is one of our answers. Let's just see if there's another one. 6 times, so now we're just going to multiply across top. 6 times x. 6 times 18 would be, that's a big number. So 48, 108 maybe? Plus 108. So that obviously is not it. And then this last one, keep, change, flip. So we're going to do 6 over x plus 6 times our x plus 3, x minus 3. And then this is x minus 3. And we should see that what happens here is these x minus 3's cancel each other. So when we multiply the 6 times the x, we get 6x. And the 6 times the 3, that's 18. And all we're left in the denominator is x plus 6. So obviously that one doesn't match either. So that means that is not the answer. And so our answer is actually B. All right, so with 22b, we're going to simplify this, and we're going to do so by factoring, okay? So what we're going to do is we want to find out what are the factors of 3 that add up to be negative 2. So let's go ahead and do that over here. So 22b, we're going to simplify this, and we're going to do so by factoring, okay? So what we're going to do is we want to find out what are the factors of 3 that add up to be negative 2. So let's go ahead and do that over here. So 22b, we're going to simplify this, and we're going to do so by factoring, okay? So let's go ahead and do that over here. So that's going to be x and x. So the factors of 3 that add up to be negative 2 would be minus 3 and plus 1, right? Okay, and then what I want to do with this denominator first is I'm going to write it in standard form. So now, hopefully you can see that if we factor out a negative 1 out of that, we're going to get one of the factors we have in the numerator. So we got our x minus 3 and our x plus 1 here. And then we're going to factor out a negative 1 down here. So we're going to get x minus 3. So now you should clearly notice that those x minus 3's cancel each other out. So we're left with x plus 1 over minus 1. Now there's a couple ways we can do this. We can just divide both of those by negative 1, or we can multiply them both by negative 1. Doesn't really matter, but our answer is going to be negative x minus 1. So the next one says, graft the function, which of the following represents the graph that Virat created. Okay, so what we want to look for here is some vertical asymptotes, horizontal asymptotes, and also some zeros. Okay, so the first thing I'm going to do is I'm going to factor the numerator to see if we can figure out what the zeros of this function are. So that if I factor out, all of them have an x in them, I noticed that, so I'm going to factor that out first. So that gives me plus 6. And I'm pretty sure that can be factored some more. So let's see, what are the factors of 6 that add up to be 5? So that would be x plus 2 and x plus 3. And then our denominator, we can factor out a 4x out of 4x squared minus 4x, so 4x. So that's going to be an x minus 1. So I noticed that we have an x and an x in the numerator and the denominator. So those are going to cancel out. So that's going to leave me with an x plus 2. Sorry, that's a parenthesis. And an x plus 3 over our 4 times our x minus 1. Okay, so now let's talk about the zeros of our function. So to find the zeros, we set the numerator equal to 0. So that's going to be x plus 2 equals 0. So x equals negative 2. And x plus 3 equals 0. So x equals negative 3. Okay, so now let's look at this video. Let's look at these different ones. So what we want to do is we want to look at the zeros. So we're going to look for zeros at negative 2 and negative 3. So this one has a 0 like out there somewhere. So that wasn't negative 2, negative 3. So we know it's not A. This one again, negative 2, negative 3. Nope, no zeros there. This one looks like it could have one at negative 2 and negative 3. Yeah. And this one as well at negative 2 and negative 3. So ish. Yeah, well, I can't push my dots very well. Anyway, you guys get the drift. So I don't think it's A or B, but maybe C or D. So I want to go ahead and now look at the wholes. So remember, we have a repeated factor. I have it right here circled in green. So that's how we find our wholes, right? So that means we would set that factor x equals to 0, right? So then we're looking for an x that's at 0. And yep, there's our whole right there. Y'all see it? That was our whole. So it's got to be C because that's where our whole was, okay? All right, now number 24 says Misty solved the rational equation and found the solutions of 1 and 3. Which statement's true? So I want to go ahead and factor this denominator right here just to make sure there's no new factors there. So what are the factors of 15 that add up to be negative 8? That would be negative 5 and negative 3, right? Which are the ones we already have. Let me go ahead and make that bigger so you guys can read it. That's x minus 5 and x minus 3. Those are the ones we already have. Now remember, to find our excluded values, we have to set those equal to 0. So we do x minus 5 equals 0. So x cannot equal 5. And x minus 3 equals 0. So x cannot equal 3. And it says that they found the solutions of 1 and 3. Which of the following statements is true? So if 1's a real solution and 3 is an extraneous solution, that would be the answer, right? Because they found both and 3 cannot be an answer. So the number 25 is what's the domain for the function. So what we want to do is set our denominator right here equal to 0. So this is going to be x minus 4 equals 0. So x cannot equal 4. So this is going to be all real numbers except for 4. And so that's D. All right, so number 27. Wait. Let me go back and make sure I didn't skip one. I did. 26. Okay, Song is solving this problem for x. She uses the steps shown. So She definitely isn't doing this problem the way that I would. So let's go ahead and work this. It says she checks her answer and finds that it's not a solution to the original equation. So she writes no solution. Unfortunately, Song made a mistake while solving. Find her error and calculate the actual solutions. So if I'm doing this problem, I'm going to do the 3x plus 11 over x minus 4 and set that equal to our 4 over x times x minus 4. So what I want to do is get a common denominator, and what I see is missing on the left that is on the right is the x. So I'm going to multiply both the numerator and the denominator by x over x. So now we have a common denominator, and recall once we have the common denominator, all we have to do is the top part of this problem. So x times 3x is 3x squared. X times 11, that's 11x, and that equals 4. We're going to go ahead and move that 4 to the left. So it's going to give us 3x squared plus 11x minus 4 is equal to 0. So now we can either use bottoms up or we can use the drop down method. So I'm going to go ahead and use drop down. I'm going to put 3x in both sets of parentheses here. And I'm going to look at 3 times negative 4, that's negative 12. So we're looking for the factors of negative 12 that add up to be 11, right? So that's going to be what? Positive 12 and minus 1. So then what we want to do is divide both of those sides by, well, we want to go ahead and GCF that. So that's going to give us x plus 4 and 3x minus 1. So we're going to set each of those equal to 0. So x is equal to negative 4, and then we're going to go 3x equals 1, and then divide both sides by 3. So x is also equal to 1/3. So those are our two solutions. And again, if we were to set both of our denominators equal to 0 to see our excluded values, x cannot equal 0, and x cannot equal what? We would do x minus 4 equals 0, so let me show you that. So x minus 4 equals 0, so x cannot equal 4. Well, neither one of those solutions are 4, so both of these solutions are indeed correct solutions. So number 27 says Tamika finds an expression for S of R that gives a surface area of a square inches of a cylindrical can with a specific volume, fixed volume in terms of its radius r in inches. Below is a part of the graph Tamika uses if she allows r to take on any value between -1 and 5. So r would be our domain, which is our x values, or our x values would be our r, what we would typically think of. So she has, notice here, from -1, which we can't see the 5, but that's what that was. So it's part A says what would be a more appropriate domain for Tamika to use instead. Obviously, we can't have a negative radius, so it would make more sense for the domain to be all real numbers greater than 0, right? Because again, we wouldn't have a radius of 0 either. Part B says, what is the approximate minimum surface area for the can? So surface area is what the S of R is, and that's this axis. S of R is what that is, okay? So if we're looking for our minimum, right, then we're looking for something in there, and it's saying surface area, right? So that doesn't look to me like it's 20, which is our first answer, and it sure don't look like it's 4, and it's definitely not a negative. So it must be around the 16, which it kind of looks like it is about 16 right there, okay? Then part C says, consider the intervals shown. Which interval for the function S of R represents an increase in the surface area? So if we look at the interval for the y here of between 16 and 60, so 16 was where we were, and 60, it was definitely not increasing in that area. For our y values, it's actually going down, right? And then for our x values from 0 to infinity, from 0 to on to infinity here, it's definitely not increasing the whole way there. So it's not 1 or 2. And then from 1 to infinity, that's from here on. So that would be the graph from there to there. That's definitely increasing. So that's certainly one of them. And then we've got from -60 to 0. And -60 to 0. So -60 to 0, that was definitely decreasing, so that was definitely not it either, so it can't be that one. And then from 2 to 3, that would be from here to there. And yes, again, what do we see the graph doing from 2 to 3 there? It is increasing, so that would be our other one. So that means our answer must be 3 and 5, which was B. So number 28 is to simplify the expression. This is a division problem, so we're going to keep our first term, change our sign to multiplication, and then flip our second term. So what I'm going to do first is I'm just going to rewrite the problem up here. So we're going to say 2x squared minus 13x plus 21 over x minus 7. We're going to multiply that times our 8x plus 40 over our x squared minus 9. So now what I'm going to do is I'm going to factor the numerator. So I'm just going to go ahead and do the 2x and the 2x and then find the factors and simplify it. So I'm going to do 2x here and 2x here. What are the factors of 42? Because when I multiply 2 times 21, I get 42. That add up to be negative 13, and that would be minus 6 and minus 7. And that could be simplified by dividing by 2. So that's going to be a x minus 3 times our 2x minus 7. And that's over our x minus 7. And then we're going to multiply that by, let's go ahead and factor this one. 8 comes out of both of those, so that's going to be x plus 5. And then this is going to be x plus 3 and x minus 3. Okay, let's see if we can simplify anything in this thing. Looks to me like we have an x minus 3 in both the numerator and the denominator. And I don't see anything else that we can simplify in this particular problem. So our answer is going to be, and I'm going to write it in blue over here. I'm going to go this way, if that's okay with you guys. We've got our 8, and then we got our 2x minus 7 over an x minus 7 times an x plus 8. So that was our most simplified version of that expression. All right, so the next one says, which rational expression is equivalent to the given function? Okay, so to do that, we're going to have to look at all of them. So which rational expression is equivalent? So what I want to do is go ahead and give these a common denominator. So I'm going to go 6t over t minus 11 plus 12, sorry, that's a 13t over, and I'm going to go ahead and factor this so we can see. So we got a t minus 11 and a t plus 2, right? Because that's the factors of negative 22 that add up to be negative 9. So that means over here I got to multiply to get a common denominator, right? So to do that, I'm going to do t plus, multiply it by t plus 2 over t plus 2, because now I have my common denominator. See it? So we're going to multiply t times 6t. That's going to be 6t squared. And then 2 times 6t, that's 12t plus 13t, all over our common denominator now, which is t plus 2 and t minus 11, right? So we've got a pair of we've got a pair of like terms here, right here, so we can combine those. So our answer is going to be 6t squared plus 25t over, again, our common denominator, which we're going to make it look exactly like it's up there. So we got t minus 11 times t plus 2. So let's see which one looks like that. So that would be D. There we go. All right, so now number 30 says simplify the expression. So this time, I don't see anything that we could factor out of either one of those. So the easiest thing to do here would be to rewrite the problem 5x over x minus 4 minus 7 over 2x minus 9. And keep in mind that we got to get a common denominator, so we're going to multiply by both of them by the opposite denominator. So this is going to be multiplied by 2x minus 9 over 2x minus 9. And this one's going to be multiplied by x minus 4 over x minus 4. Okay, so now we have our common denominator. Notice that these are the same now. So that's going to be equal to 2x times 5x. That's 10x squared. Negative 9 times 5x is going to be negative 45x. And then we're going to multiply this negative 7 times the x. That's going to be minus 7x. And then negative 7 times the negative 4 is going to be 28 plus 28. That's all over our x minus 4 times our 2x minus 9. Okay. Now I see a pair of terms that are like terms that we can combine right here. So that's what we're going to do to get our answer. So it's going to be 10x squared minus 52x plus 28 over our x minus 4, 2x minus 9. So that answer is C. So again, when you're doing this, when you're checking those answers, guys, make sure you check every sign because these are the same answers. The only difference is the sign of the 28 right here. See it? So be careful when you're choosing your answers there, okay? The next one says solve and state the extraneous solution. So the first thing I want to do here is I'm going to factor. So I got my 3x over, and I'm going to factor out the 6, and that's going to give me an x minus 5, and that equals 2x plus 3 over x minus 5. So I notice that I have already a partial common denominator. So what I need to do to get a common denominator on both sides is just multiply this one by 6 over 6. So that's going to give me 3x. And remember, now all we have to do once we have that common denominator is multiply across the top. That's equal to 12x plus 18. So I'm just going to subtract 12x from both sides. So that's going to give me minus 9x is equal to 18. Divide both sides by negative 9. So x is equal to negative 2. And to make sure that that's not an extraneous solution, we're just going to set this x minus 5 equals 0. So x cannot equal 5. So that was our solution. So on the next one, I don't know why I can't see it all. I guess I didn't clip it all very well. So I'm going to go ahead and write it here. So I got a 2x minus 9 over x minus 7 plus x over 2. And that equals, I don't know what's going on with my pen again, x minus 7. So I need to get a common denominator again. So what I notice is the different factors in the denominator are 2 and x minus 7. So I'm going to multiply this one by 2 over 2. I'm going to multiply this one by our x minus 7 over x minus 7. And then I'm going to multiply that last one by, again, 2 over 2. Okay? So that's going to give me 4x minus 18 plus x squared minus 7x equals, that's 10, right, y'all? Okay, so we're going to combine our like terms and put this in descending order. So this can be x squared minus 3x minus 18 equals 10. So now we're going to subtract the 10 from both sides. So that's going to give us x squared minus 3x minus 28 equals 0. So now we have to factor this. So x and x, what are the factors of negative 28? That up to be negative 3. That would be minus 7 and plus 4. Set both of those equal to 0. And so then our x is going to be equal to 7 and x is equal to negative 4. And again, we need to look at our excluded values. So we're going to set our factor, which is x minus 7, equal to 0. So x cannot equal 7. So this is an extraneous solution, right? So that doesn't really count. This one does, okay? So the extraneous solution was the 7. The actual solution is the negative 4. Okay, on this next one, it says find the zeros, holes, vertical and horizontal asymptotes to my range, intervals of increase and decrease, and behaviors. Factor this thing first, okay? So I'm going to create a couple sets of parentheses here in the numerator and the denominator, put some x's here. So we're looking at the factors of 2 that add up to be negative 3. That's going to be minus 1 and minus 2. And then the factors of negative 10 that add up to be negative 3 would be minus 2, and plus 5. So notice that we have a minus 2 in both the numerator and the denominator. So our function is going to end up being x minus 1 over x plus 5. All right, so now what we want to do is find our zeros. So to find our zeros, we set our numerator equal to 0. So we're going to say x minus 1 equals 0. So x equals 1. Then we're going to find our whole. That's the next thing it says up here. So to find our whole, we're going to set our repeated factor, which is x minus 2 equal to 0. So our x is equal to 2. Then we're going to plug that 2 back into our equation. So our y is going to be equal to 2 minus 1 over 2 plus 5, which is 1/7. So our whole is going to be at 2 1/7. Okay, then it's asking us for our vertical and horizontal asymptotes. So our vertical asymptote is going to be equal to our denominator equal to 0. So x plus 5 equals 0. So x is equal to 5. And then our horizontal asymptote, we're going to take these degrees, x over x, and that's equal to 1 over 1, which is equal to 1. So that's our horizontal asymptote, is y is equal to 1. Then it says domain and range. Okay, so remember, what affects our domain and range are our wholes in our vertical asymptotes. That's our domain. And so I'm going to do these right over these. So our domain here is going to be all real numbers except the value of our whole, the x value of our whole, which is 2, and our vertical asymptote, which is 5. Okay, and then our range is going to be similar, only it's going to be all real numbers except, again, the y value of our whole, which was 1/7, and our horizontal asymptote. Okay. All right, then the next thing it asks us for is our intervals of increasing and decreasing. So to do that, we're going to look at a graph. Oh my gosh, why? So I went ahead and put this in decimals, and I'm looking at here. So our intervals, this looks like it's increasing from negative infinity to our vertical asymptote. And then it's also increasing on the other side as well. So let's go back and do this one. So it wasn't decreasing at all. So we can say increasing, right? So from negative infinity. So what's our first place? Is it our whole or our vertical asymptote? Looks like it's our whole, right? So that's going to be 2. And then we're going to pick that back up at 2 and go on to our vertical asymptote. And then we're going to pick that back up and go on to infinity, okay? So this had decreasing none, right? All right, and then the last thing it was asking us is about end behaviors. So as x approaches infinity, f of x is going to approach our horizontal asymptote, right? Which is what? 1. And as x approaches negative infinity, f of x is still going to approach, again, that horizontal asymptote. Okay, so now let's look at this next one over here, and we're going to see what we can determine by looking at this graph. So it looks to me like we have a horizontal vertical asymptote. We have a 0. Okay, so let's look at the 0 first. So because it's asking us about our zeros first. So there's a 0. So that looks to me like our 0 is at x equals 3, okay? Then our vertical asymptote. Nope, let's make it blue like it is in the drawing. That would make more sense. Our vertical asymptote is here, so that looks like it's actually at 2.5. X equals 2.5. And then our horizontal asymptote is y equals, it looks like it's at -2. So y equals -2. Doesn't look to me like we have any holes. So we're going to say holes, none, because there are no open dots. Okay. Then we want to look at our domain and range. Okay, so our domain is going to be all real numbers except, and we don't have a whole this time, so all we need to do is talk about our vertical asymptote. And our range is going to be all real numbers except our horizontal asymptote, which is -2. Okay? Then when we're talking about intervals of increase and decrease, okay, so increasing, do you see it increasing at all? Look what the graph's doing. Yeah, no. It's going down and it's going down. Y'all see that? So this has none. So then if we're talking about decreasing, we're going to say it's going from -infinity to our vertical asymptote. Y'all see that? So that's going to be at 2.5, and then it's going to pick back up on the other side of 2.5, and it's go on to infinity. So remember, those dashed lines we are not included in our domain, in our range, and they're also not included in our intervals, okay? Then when we're talking about our end behaviors, so as x approaches infinity, f of x approaches our horizontal asymptote, which was -2 this time. Okay, and then as x approaches negative infinity, f of x still approaches what? That horizontal asymptote. So for 35, we're going to factor. Okay, we've got 3 different factoring problems we're going to do here, and I'm going to show you a couple ways to do both. Okay, so first of all, I'm going to use my drop-down method. So that's 5x, where I put the 5x in both sets of parentheses. Okay, I'm still going to multiply the 5 times the -4. That's going to give me -20, right? So I'm looking for the factors of -20 that add up to be -8. So that would be what? -10 and +2. Okay, notice there's a GCF here, so we're going to divide by that. So that's going to give us x minus 2 and our 5x plus 2. Now, if you want to use the bottoms up method, we would still do x and x, right? And we would still do our 2 factors, which would be -10 and +2. Now, this time, we would divide by the 5, okay? And if the 5 doesn't go in, then it goes bottoms up. So -10 divided by 5 is x minus 2. And then we brought that 5 up. So this is going to be 5x plus 2. So notice the factors are the same no matter which method you use. All right, so the next one, I think this one has a GCF of 3, y'all. I think all of those numbers are divisible by 3, so I'm going to factor that. And actually, all of them have an x as well, so I'm going to factor out a 3x first. That's going to give me 2x squared minus 11x plus 14. Okay, so now we want to look at multiplying 2 times 4. That's 28, right? So we're going to look for the factors of 28 again. So I'm going to still have my 3x out there, and I'm going to go ahead and do my drop-down method here. So I'm going to put my 2x in both. So we're looking at the factors of 28, positive 28, that equal -11. So that's going to be -4 and -7. Okay, notice there's a GCF there of 2. So this is going to be 3x, and this is going to be x minus 2 and 2x minus 7. And again, you could have used the bottoms-up method. Doesn't matter which one you use, okay? All right, so this last one, I'm going to factor out a -1 first. And so then when I do that, I get x squared plus 5x plus 6. Okay, so that's going to be a -1 times x. What are the factors of 6 that add up to be 2? That would be plus, or to 5. That would be x plus 2 and x plus 3, right? So those are our factors there. So good luck on the final, guys.